So, anyone knows annotations in Java? So you must have seen something like this, at the rate and name, something like this. So this is very much similar to annotations. Okay. Now we have used these two decorators, that is static method and second one we use, that is class method, right? Okay. So what is decorators? So decorator is something, it will, so we have seen functions. So for function, we used to pass a lot of variables, be it two variables, three variables, be it variable length arguments, be it keyword arguments, right? So decorator is something, it will take function as an argument, okay, and it will return one function. Okay, it is not at all mandatory to use decorators, okay, but it's just a better way of writing your code. Now what is the use case of decorators? Okay, so let's say you have written one function a, okay, it is working fine. Let's say this is a function of 1000 lines, okay, working perfectly fine. Now there is some change in this function, okay, new functionality is there, so you got one CR, now you have to make some changes, okay, but you don't want to actually modify this function because it's working perfectly fine, okay. So what you can do, you can create one wrapper around it, okay. So you can create one wrapper around this function, and so this wrapper function ultimately give a call to this function a, but with some modification. So your modification code you will write in a wrapper, and inside that wrapper you will call this function a, okay. So such wrappers you can create using your decorators, okay. So let's take an example. I have a function called concat, okay. I pass two values, it will just concatenate the two values for me. That is the only purpose of this function. Let's say this returns result. Okay, so here I'm passing two integers. Now let's take two strings. Okay, and here I'm writing this, okay. So concat function, first I'm passing two integers, this time I'm passing two strings, and I'm passing one integer, one, okay. Now let's say while writing a definition, I haven't handled this typecast condition. Okay, so this just returns me val1 plus 1. Okay, now if I execute this, obviously it will throw an error in this case, right? So just comment this out, let's see. Okay, so for two condition it is working, but now it will throw an error for the third condition because you cannot concatenate integer and your string, right? So I don't want to change this function at all. Okay, I have written this. Now this is the final version. I don't want to make any changes in this. Okay, I want to write one wrapper function for that. Okay, so one line above this, you will go and you will write at the rate, which will tell, okay, this is a decorator. Okay, and you will specify user defined decorator name. Okay, now this can be anything. So I'm saying decorator underscore function. Okay, so this is user defined name and this is mandatory. Okay, so with just above the function you will pass this decorator function. Okay, now whenever you are defining one decorator you have to define this particular decorator also. Okay. All right, so this is normal function which will take a function as an argument and it will return one function. Okay, so I'm writing def decorator function. All right, now the function which is below this decorator will be automatically passed as an argument to this decorator. Okay, I'm accepting this as a func. Now this func is actually this concat function. Okay, so how it will work, whenever you are giving a call to this concat function, okay, it will go here, it will see, okay, there is a decorator. So before actually giving a call to this concat function, it will pass the control over this particular decorator function. Okay, now the purpose of this decorator function, this is like a middle function. It will take one function as an argument and it will return a new function as a result. Okay, return, let's say so it will take one argument, this is the underlying function, and it will return one result. Okay, so whatever inner function you are writing, so this is your actual new modified code. Okay, so whatever changes you want to make to this original function you can define in this inner function. Okay, so I'm writing something like this, diff inner function, and all the parameters which we have here will be automatically passed to this particular function. Okay, so the parameters which I'm passing here will be automatically available for this inner function also. Okay, now I need to write the new logic. Okay, so what I want to do, that if first I'll check the type, if type is same I will give a call to this default concat function, otherwise I'll typecast it and I will check. So this is okay, so here I'm checking if type of val1 comma val2 or equals type of val2. If this is the case, I want to give a call to this concat function, right? Now what is this concat function? So this concat function is actually passed as func, right? So I'll say okay, otherwise, oh, I need to pass the argument. So now this is my normal function call. Else return func of, let's typecast both the arguments. Okay, all right, so this is working now this case. So I'll come back to the flow again. Now it is working for all the condition. Okay, all right, let's start again and let's observe what just happened. Okay, so I'm writing one function called concat. I'm passing two arguments to it, and what this function will do, it will just return the concatenation of two values, right? But now this will fail if I pass two different arguments. That is, if I pass one string and one integer, it will fail. So to prevent that, we have something called wrapper functions, and that is a decorators. Okay, so how to define a decorators? We will specify the @ and the decorator name. Now this is user defined. Okay, so you can give any name to it. So how it will work, whenever there is actual function call, that is concat, it will go here, but it will say, okay, there is a decorator before this. Okay, so instead of directly executing this concatenation function, it will actually execute this decorator function first. Okay, now this decorator function is nothing but a middle function. It will take one function as an argument and it will return another function. So once it comes here, it will pass the control to this decorator function. Now the underlying function which we have, that is a concat function, will be passed as an argument to this decorator. Okay, so this is the argument. So this is the input to this decorator function. Now this decorator function will take input and it will return one another function as an output. Now this another function which you are writing, that is this inner function, this will be your new modified function. So you need to write your new code in this particular function. Okay, so the structure will remain the same always, that okay, you will define a decorator like this, and it's just your logic which you are defining here will be different for your different decorators. Okay, now I'm defining this inner function. So whenever it goes inside this decorator function, this is a function definition. It cannot execute it directly unless and until there is a function call for this, right? So it will look, okay, this is a function call. It will go here, it will start executing this function. Now for this function, the parameters which you are passing to the original function will be passed automatically. Okay, so all the parameters will be available here also. So in this example, what I'm doing, I'm just checking type. If type is same for both the functions, I want to give a call to this concat function normally. Okay, I don't want to change anything. Now this concat function is actually passed as a func, right? So this is not as a concat. So I'm saying, okay, give a call to this and return me the answer. Okay, now where this answer will be returned of this inner function?
From the calling place.
Exactly. So this inner function is getting called from this decorator function, right? So the answer will be here, and this will be returned back to the original function here. Okay. Otherwise, yeah.
We don't use the current system.
No, as a reference it will be passed. Okay. So I'm saying return. If type is not same, then do typecasting for this. Okay, and return me the and give a call to this original concat function using this. Okay, so program flow, start here. Okay, decorator, so go in a decorator first. Once you are inside a decorator, there is an inner function which will be executed, so go inside inner function, and from inner function give a call to this concat function. Okay, and the concat answer will be returned here. Now this is return, so it will be returned here, and this is your final return to your function. Okay,
When we run the result statement, when you come down, let's say any other result equal to concat 10. So that means we are calling concat function.
Exactly.
It finds
decorate. So there is a decorator.
That is why it
goes up. Yeah. Okay. Try one example. So basic one. So okay. So I have a function called print site name. Okay, whatever site I'll pass here, it just print like this only. Okay, what I want, write a decorator. So it should append something. Let's say welcome to is a string. It should append to this Google. So if you print it, the answer will, even though you are passing this www.google, it should print me. Okay. So try this one.
So, the definition for this escapes so when we follow the function, it will get
So we are calling this func, right?
Mhm.
Now what is this func? So func is ultimately a concat function only. So from this modified grapher function, we are calling this concat function.
This will not be executed either.
Which one?
This.
Yeah, so it will be executed in return here. So, okay. So this concat function, okay, so I am passing this as a parameter to this func here, right? Now here I'm giving a call to this func. Now, okay, now focus on this part only. Func val1 and val2. Okay, it will give a call to this. Ultimately func is nothing but a concat function. So go here. Okay. So calculate this val1 and val2, and this is return. What is return? So it will return to its college. So it will get result here, right? Now return this result back to here. Now from here, return the final result to the top.
No, what is the return type for this inner form? String, right?
Which one?
Inner form, this return.
Yeah. Same.
Then this name should be same to the function name or
Which one?
select this inner form. This
Uh-huh.
select any name.
Yeah, this can be anything. So, yeah.
And is it mandatory to define another function inside this decorator function?
Yes.
You can't directly give the statements which you are giving is the.
So ultimately, you need something as a modified function. Okay. So this decorator function is just a wrapper. It will just take one input, give a call to another function. That's it. That's it. A middleware, we can say.
But it will be called implicitly when we call the.
Yeah.
Similar way.
So structure will be exact similar. Yes. So definition and inner function.
Returning the same calling function and same variable. It will return this welcome to welcome.
No. So what I said that in this function of the string type name, it will be only exact return. So if I'm passing google.com, this particular function will be returning only google.com. You have to append that functionality here in a modified way. Okay. Alright. Let's try this. So I have something definition, print site name. Okay. So okay. So I'm saying whatever value I'm getting here, my function is returning that only. It's not doing any concatenation, nothing. Okay. So I'm not taking into results, I'm directly printing it. Okay. So this is my function call. So now if I execute this, I'll get the exact string, right? I want something to be concatenated to this string. Okay. So I'm saying it, let's say this is a deco. Yeah. What should I write? So that's the same function name. Okay. So this is returning some function called inner function, right? Now this can be anything. It's not mandatory. It should be an inner function only. But whatever you are returning, you have to define a definition for this. I'm saying definition.
No, but when I'm trying this thing, when I'm giving different names, it's giving an error.
Oh. Okay.
No. This definite function name and return type.
No. That should be same, right? So what am I ultimately saying that this is a function call. And whenever I'm calling a function, my function definition should exist, right? Okay, so I'm saying this is a new function. Now the argument which I'm getting here will be defaultly available for this function also. I'm directly saying, okay, this is site name, alright. Yeah, so I'm here that ultimately when I give a call to this print site name, now it will give a call to this new function. Okay, so
Welcome to single quote. Then you can call it function site and you can pass a parameter site name.
So this is one string, right? And
Plus.
So if you put comma, ultimately you're returning two different values, right? It's just I'm putting one plus, which means same values. Okay, from here. This is a function name. If I'm writing func, means I'm calling print site name. And I need to pass the site. Okay. Alright. So your structure will always remain the same. That you will define a decorator like this and you will write your entire new logic here.
Any libraries suitable?
Nope.
And what's with the recursive function?
Yeah.
Any function which has a return.
Anything you can do.
So decorator also defines some other class.
Class is also fine.
Also.
Will work.
Do
Yeah.
the parameters?
So you're passing parameters, right?
Yeah.
So all parameters will be available.
Okay. If it is private also, it press the decorator.
Yeah. So then you have to check that condition whether you're passing private or not. If it's private, then yes, obviously issue. But generally, you will define your entire decorator inside a class, right? So in class, what you generally write multiple definitions, right? So for one particular definition, you are defining a decorator, and it will be inside the same class definition. Now, as this is inside a class, even though you're passing your private variables also, it will work. Okay.
One question. We can put that return statement in the bracket then.
Which one?
The def in function, the return function is there, right?
This one, right?
Line number 44. So if you put that in
no problem. Okay. On the same. Okay.
So what is the significance of?
So generally, if you see in other programming languages, you will define like this. Okay. In Python, it is not necessary, but this is the same thing as even if you add a semicolon, Python will not throw an error. It's the same thing. Okay. So you don't need this, but just to avoid complexity, you can add parentheses. Okay.
Instead of passing www.google.com, can you pass your username?
Now it will come down to your function logic. Now if you pass integer value, obviously it will fail because you are here string plus this.
You see it, the quotes are there.
Okay. So because ultimately this is returning a value, right? Now whatever value I'm getting, okay, typecast it. You're getting error? Okay. So just to provide a scalability, this feature is provided in Python. Okay, so you have a function which is well defined. You want to add or change some functionalities, you can define a wrapper function and work with the same function only. Okay. Any queries?
So every time we'll call this function,
Ultimately, yes, it will be making this much number of function calls.
Really, we can write some similar logic in the actual function.
Yes, so you are modifying the actual function in that case. Okay, if you want to avoid this, but still your code should work.
Whenever we call the actual function, the same that logic is going to follow.
Yeah, so you are not touching a single line of code in this function, right? So it's the thing is like you know what is input to this function, you know what is output of this function, right? Now you don't know where exactly to make modification, right? It's, let's say, part of separate R&D, right? So you know input, you know output. Okay, I'll write a wrapper function. The work will be I'll just pass the inputs, the format in which this function requires, and I'll export that. That's it.
Can we write decorator for existing built-in functions?
Built-in functions? No. Because that will be like overriding it will be. Okay.
Underline increases the function pointer.
Yeah. So it will take the same function as a pointer.
Like in a way, we can take multiple functions. Like
so you can define a common decorator. That is possible.
With some condition, I want to call one function, another condition, like different function. So how do you do it?
So multiple decorators. That's the only solution. Yeah. Different decorators.
We cannot have error function pointers. It's fast.
No, here no. You have to define multiple decorators. If you want to do that, then you can pass keyword decorators. Okay, that is something possible, but ultimately you are adding third degree of thing. Okay, so how it will work? That you will pass a keyword here. Let's say something like username. Okay, this is something it is taking as a parameter. That if this is the thing, you have to call this. And here it will build one more complicated thing that okay inside this decorator, so your top level decorator will be now your keyword decorator. Inside this decorator will be, so 3 levels of it. Okay. So you have to manage your complexity also. Okay, so in web development, this decorator concept is used a lot. Okay, so in Python, we have seen these two decorator, class method and static methods. But in Django, we have a lot of, so we have a concept called pre-signal and post signals. Okay. So it's example of your decorators that these are built-in decorators. It will generally use that if you're specifying, if you're doing any operation on your database, post signal is something before clicking on save, you want to continue, you want to conduct a set of operation. So you'll just define a post save decorator and all the functionalities you can define there. Pre-save is same like before actually saving it, you want to run a particular set of operation, you can define into pre-save, something like this. Okay. All right. Next thing, let's start with threading. Anyone worked with a C or a Java threading before? Yeah. All right. Okay. So if you want to achieve concurrent execution, you can go with threading part. Okay, so generally threading is used that if you want to perform some operation asynchronously, that user is working on something, but if it executes in a same thread, it will ask user to wait for some time. Then that particular operation you can do in a background thread, so that user don't have to see that wait time, right? So if I'm writing a normal code based on my functions, let's say this is definition 1, This is definition 2, and this is my call of definition 1 and definition 2. Right, so while working, if I have a normal flow, it will call this function 1, okay, execute this entire function 1, then let's say function 2, execute this entire function 2, and then stop the execution, right? Now let's say this definition 1 is completely related to your database updations, okay, so which you can do in a background also. So if it's a normal execution, you can see that your program is stuck for a split seconds, but you want to avoid that, you don't want to give any wait time, you can go with your threading. Okay, now again, so threading was popular whenever you were having less resources but you want to achieve concurrent execution, right? But nowadays we are getting high capacity servers, so this is the programming decision you have to take always, whether you want to include the complexity of threading to your programs, because it will make your program significantly complex adding threading. So you have to make a judgment that whether it's important to add a threading or existing, you can increase the existing infrastructure and get these things done. Because we are getting servers and everything at a cheaper cost nowadays, so this is the decision you have to take. Okay.
Because it's to save your cycle time, right?
Exactly, exactly, exactly.
So whenever, I mean, if there is a need of logic to run,
Parallel, yeah. So see, concurrent and parallel execution, these two things are different. Okay.
Are different?
Yes, yes. So generally what we have, so I'm running one, so this program, so I have one CPU, right? Let's say this is quad core. Okay, so when I say concurrent, okay, so I want to distribute the loads among these four cores, right? Whenever I say parallel, which means I will have multiple CPU, okay, and I want to distribute the loads among this five. Okay, so if I want to achieve it on a single processor, this is my concurrent execution. Okay, so if I have multiple CPUs, it will come under my parallel processing. Okay, so
And each of these five CPUs might have four cores.
exactly, exactly. So you will decide that, okay, this particular task to be executed. So generally we call it as the workers, right? So each CPU will be a worker, and we will decide the task, that what is the main functions of this particular worker, that which functions this works, right? So let's say whenever we have architecture like application server and a web server, so in an application server we can have multiple workers. So because whenever users make a request to the application server, we don't want that at a time one server can only make a request. So we can have a pool that this application server will have, let's say, 3 workers, and having a load of handling 100 users. So it's not that there are 3 users, you will directly distribute it to worker 1, worker 2, worker 3, right? So to make it efficient, let's say worker 1 can handle 100 users efficiently. So if there is a load of 100 users, yes, I will only use my worker 1. But if my load goes beyond 100, I will ask your worker 2 to handle next set of 100 users, right? Yeah. So using this threading module, we will be mainly focusing on concurrent execution only. Okay. So for that, we have to say import threading. Okay. So in Python 2.7, this library is called thread. It is not available from Python 3.0. We have a backward compatibility version, that is underscore thread available. Okay. But going forward, new features will be added in here. Okay. All right. So let's take a simple example. So I'm writing 2 functions. So I pass a number to this function, it will return me the square. Okay. And let's say I'm writing definition multiply. So if I pass two numbers to this, multiply function, and this will just return intent. So if I give a call, right, let's print it. I cannot make a return here. So if I give a normal call, that is square of 10, right? So it will pass the control over the square function, execute this and print this. If I say multiply 10 comma 20, it will pass control this and execute this part, right? Now I want these two functions to work simultaneously. Okay. So for that I can create two separate threads and I can ask these two threads to execute concurrently. Okay. So how to create thread in Python? So I want to create these two threads. Okay. So I'm creating an object of a class thread. Okay. So I've discussed that for convention to define a class, generally it is used as a capital letter, right? So this is a module. This is a class name. So in short, when I give a call to this thread, it will ultimately invoke which method? Init method of this class thread. Okay. All right. Okay. I need to specify what is the target of this thread. Okay. So I'll say target. So this is a keyword argument. Target is equals to square. Okay. Okay. I need to pass that. Okay, so this square function takes one argument, right? So all these arguments you can pass using this keyword, that is args. Now it should be a tuple. Okay, and by syntax, if you are passing a single value, you have to put a value and a comma. Okay, otherwise it will throw an error. Okay, so far I have defined two threads. I have specified the target for this. That okay, so the target for this is square function, and the target for second function is multiply function. Okay, to pass the arguments, I can make use of this second keyword, that is args. Okay, it should be a tuple, so whatever value you are passing, you have to pass it in a tuple. Okay. Now I have just defined two threads. I haven't started the execution. So if I execute this now, it will not show anything. Okay. Now in order to start the execution, we have to invoke a method called start. Okay. So now you can see, I don't think you can see some difference in output. All right, let's tweak this. So I'm saying something called import, um, and here I'm saying time dot sleep. Okay. Now you can see that it went to this inside square function, okay, but now there is a sleep of 10 seconds, so it's still waiting. So this particular statement is not getting executed, but meanwhile it actually started execution of this inside multiply function. That means it started execution of multiply. It executed these two statements, but it was waiting for this first function to complete the execution, right? So you can see it's not showing this finished yet. It's waiting. It will wait for 10 seconds, and after that it will print the output 100 and it will finish it. Okay, so defaultly you will have one process. When you do not create any thread, you are working using one process, right? When you are creating threads, you are saying that okay, I'm creating two threads under this process. So it depends on the CPUs. Okay, so whenever I'm executing on multiple cores on a single CPU, okay, so I can say okay, I'm executing it on concurrently, okay, but it's not a parallel execution. It's a concurrent execution. Okay, but when I say I'm executing on multiple CPU, multiple different physical CPU, it will be a parallel execution. Okay, so I'll be scheduling the function not on the CPU, not on the cores. I'll be scheduling on a different system.
But from user perspective, is running the code.
So it's not important that on which system it is getting executed. So user will just perform some task in the background. You have to decide, okay, if there is a load, you have to automatically redirect to the CPU 1 or a CPU 3 or a CPU 4.
But it looks same.
Yeah, it will be look same. Yeah, it completely in background. Right, so here, so the work of this process will be to ensure the execution of all thread is finished. Okay, so that's why there is one process and you are executing two threads. So it will complete the execution of thread 2, but still this is waiting for your thread 1 to complete its execution. That's why your process will be waiting for this thread to finish the execution. Once this is done, it will print the output and it will show that okay, execution is finished. Okay, so this is how I can create the threads. Okay, now let's say you want that these two methods are dependent on each other. Okay, you want to make sure that unless and until the execution of thread T1 is finished, I don't want to start the execution of T2. Okay, so we have something called join. Okay, so whenever I say T1 dot join, I am saying to the process that wait until T1 is finished. Okay, so now if I execute this, so inside square function, now it's not starting the execution of T2, that is it's not starting multiply function, it's still waiting. Okay, so your T1 will complete it, now it will start execution of T2. Okay, but because of this, let's say there is some issue with your thread T1, right? Now because of that it's not able to complete the execution, it's still halted. Okay, so due to the issue in T1, now your T1 is also halting forever, right? So you can specify the timeout. Now what I'm saying that wait for T1, okay, but there are chances that okay, I don't want to stuck forever, so I'm specifying timeout. Okay, so I will wait for not for 10 seconds, I will only wait for 5 seconds. Okay, if I get the output, well and good, otherwise I will start execution. But you can still see that it is not showing finish, it will still wait for T1 to finish. Okay, it's just now you are checking when exactly to start the execution of T2.
And, suppose the T1 gives some error, the method was giving some signal.
Your T2 will continue.
It's an exception.
Pre-steamer. How about just okay? You can still see that okay, this is inside multiply function. So it's showing exception in thread 1, but your thread 2 is executed.
We are using join.
In join, yes, so it will still wait for that time. Yeah. Then you have to control that if there is an error here, I don't want to start execution of this. Okay. Then we have concept of something called daemon threads. Any idea?
Some process that runs in background.
Exactly. So we have some processes which are continuously running in background, but these processes are not that much critical to your application. Okay. So now let's say here I have two threads. Okay. I'm saying that T1 is something called daemon. Okay. So daemon equals to true. Okay. Now we have seen if it's a non-daemon thread, your process will wait for this T1 to complete its execution. Okay. But now when I declare this particular thread as a daemon, the process will not wait to complete for the completion of this particular thread. Okay. If I execute this, it says inside a square function. Okay. I have a join, so wait for 5 seconds. Inside multiply function, and it will stop the process. It will end the process, and it will kill T1 also. Okay. So why? Because whenever I'm specifying something as a daemon, I'm saying, okay, it's fine if all other threads are complete, execution is done, then I can kill this particular thread. Okay. So this is generally used for low priority task that you don't want to run this. If all threads are done, you don't want to continue that thread also. Okay. So understood the difference between normal and the daemon threads? Now let's come back to the main point of threading, that how it works if I want to work with a global resources, right? Global resources. Let's say I'm taking one variable which is a global, okay, and both of these functions are using the same value. Okay, I'm saying something like count is equals to 50. Okay, I want to use this count, same count variable here also and here also. What should I write? So I'm saying global, right? Same thing I'm copy pasting. Okay, all right. So what I'm doing, just comment this part. I want to increment the count variable here. Let's say I'm saying for loop. I am writing a for loop to increment it just to ensure that there should be a conflict. So let's say for a range of 5, okay, I'm saying count plus equals to 1. But let's say this will increment the count by 5. After incrementing, let's ask this thread to sleep for 5 seconds. Okay, and yeah. and same thing I'm doing here. This time incremented by 2 and sleep for 1 second. Okay. Let's make it 2 and run. Okay. And the important thing, just print it first. Okay, let's execute. So it's saying inside a square function. I initialize the counter to 50, multiply 50, 52, 54. It's not causing a conflict. Alright.
Because it's only 10 seconds.
10 actually. Okay, 50, 55, 60, multiply 65. Okay, yeah. Okay. So it started with this function 1. So initially it printed 50, incremented it 5 and printed. So it looks like it's executing inside a square function. It's in the same loop, right? So it continued for 3 iterations, but then it started execution in the multiply function. It incremented by 5, but still it looks like it completed the for loop.
Because of join in between.
Well, we have a join. Now it should complete. Okay. So now you cannot say that at what time it will exactly increment it by 5 and at what time it will increment it by 2. So it started with 50, incremented by 5, then 2, then 2, then this time it is 5, then 2 again, then 2 again, then 5, 5, then I guess here also 2 and 5. Okay. So you are using single global resource, and both these functions are actually working on the same global resource, right? So you have to tackle this particular situation, and for that we can create something called locks while working with the threading. So you want to ensure that if one function is working on a global resource, we have to make sure that other function will not get access to that particular variable, right? So how to define a lock? So we have a class called lock in this same library. Okay. I'm just saying, let's see. Heading dot. Okay. So I'm creating a lock. Now this lock has two methods. One is acquire, one is release. Okay. So before actually starting incrementing the values, I'm saying we have lock dot acquire. Once incrementing is done, outside the for loop, I'm saying lock dot release. Same thing I'm doing here. Okay. So now if you observe the output, so it started inside a square function, printed value 50. Okay, but at this time the lock must be acquired by the square function, right? So even though it went to the multiply, it cannot execute this particular for loop. So by that time, this function needs to wait to lock needs to be released. Okay, so because of that, we can say it's incrementing by 5, 5, 5, 5 completely. Once these 5 iterations are done, the square function will release the lock, and then only this multiply function can acquire it again, and it will start with incrementing by 2. Okay, so whichever function reaches this lock dot acquire first will get access to that global resource and can start working on this. Okay,
How do you embed this?
yeah, so it's a same separate class on this threading library. It's a threading mod. Okay, now let's play around with this acquire and release. Okay. I'm trying to release the lock before actually acquiring it. Okay, so this is not possible. So you have to make sure you acquire a lock first, and then only you can release. Okay, but how about this? I'm acquiring the lock here. Okay, but in this particular method, I'm saying release the lock and then acquire it here. Okay, I'm commenting the statement also. So in short, in one method, I have acquired the lock. Okay, so using l dot acquire, I'm saying that in multiply function, without acquiring it, release the lock first, right? Now we have seen I cannot directly release the lock first, right? Okay, so by chance if this multiply method start execution first, it will obviously hit this log dot release statement first and it will throw me an error. Okay, but let's say now if square method starts the execution, square method will acquire the lock, but it's not releasing the lock. Okay, now let's check if multiply can release the lock or not. So it started from 50, 55, then instead of incrementing 5 again, incrementing it by 2, which means this is being executed by multiply function. Okay, so this is again 2, but this is 5, 2, 2, 5, 2, 5. Okay, so which means if I define a lock, if I have a multiple methods, okay, if one method acquires it, it's not mandatory for that method to release the lock. Okay, other method also can release it first and then start working on it, right? But this is something needs to be avoided because of this logic is working here, but it's showing me the wrong output, right? So this is one of the problem with this lock, that even a one thread acquires a lock, other thread has a permission to release the lock and get access to the global resource. Okay. we have another type of lock, and that is called as R lock, which is re-entrant lock. Okay, so now if I try to do the same thing with R lock, okay, it will throw me an error for this thread 2, which shows that thread 2 cannot release the lock. Okay, so it's showing me the error that cannot release the unacquired lock. Okay, so what is concept of your R lock? If one thread is acquiring the lock, the same thread should release the lock. Okay. Also, one more advantage it provides is that you can define more locks here. Okay, so here I'm saying lock again, but I need to make sure I release same number of locks. Okay.
So it's not getting nested. I mean, which lock will be acquired first, released first? So coming first,
So this will be acquired first. So this is first, this is, and then release two.
release will be first lock will be released or second?
A second one. It's a nested.
Nested.
Okay. All right. So now let's comment this. So this is acquire and this is release. Right? Okay. So I can acquire n number of locks using R lock. But now if I try to do the same thing with normal lock. Okay. So this is generally useful in case of your recursion. That in recursion you will be, so the same function will be getting executed again and again, right? So if I execute this with a normal lock, you can see that it will go to the square function. Okay, you can see it is running, but it's like waiting for a lock to be released. Okay, so in my normal lock, there is only one lock available. So if someone acquires it, unless and until that lock is released, the another acquire method cannot be executed. Okay. Now here I have executed one acquire. Again, I'm trying to execute this another acquire method. Right. Now for this time, it is actually waiting for this particular acquire method to release the lock. So it cannot go forward. It's just keep on waiting and waiting. Okay. So there will be a single lock when I say normal lock. That is okay. But whenever I say R lock, okay, I can create n number of locks. Okay, the only condition will be if I'm acquiring two locks, the same thread should release two locks. Okay, so it will not halt the execution, it will continue. Any queries so far? So it's not mandatory that you have to define two separate methods to work with threads. It is possible that you will create one thread, or you can create multiple threads and the target will be single method. Okay, so you can extend the example which we discussed in last week, that is beautiful soup one, right? You can create let's say 4 to 5 threads which will independently start fetching the data for different courses. Okay, you can try that exercise, because ultimately the example which we have discussed, it's fetching the data for one course, after that starting from the second one, right? Now you can write that data in multiple files, let's say. So create 4-5 threads and it will target the same method. It's just it will each time it will take new URL. Okay. So for threading, we have seen how to create a thread. So while creating that thread, I need to specify the target and I need to specify the arguments. Okay. So to actually start the execution, I need to specify the start method, right? So we have seen how to start the execution. Then we have seen something called join. So if I want to make sure that the execution of this particular thread is finished before actually going forward in the process, I can say the thread name dot join. So your process will wait for this particular thread to complete the execution. Then we discuss something called daemon threads, right? So if I define a particular thread as a daemon thread, my process will not wait for that thread to complete the execution. Okay. And we discussed how to create locks. So we have acquire and release methods, and I can define a lock using this lock and a rlock class. Okay. Again, yes, you are adding complexity if you are going with the threads. Same thing, right? So I'm creating multiple threads here, right? That's the syntax. Yeah? No. So concurrent execution, threading, multi-threading, same. Okay. So we'll stop here for today. So tomorrow we'll discuss these two topics: sockets and database access. Okay. Prasad and Karthik, I'll cover generators. So, okay. So I'll just wait.
Theoretically, application showcase we use the particular recursive
For recursion?
and numbers.
Sure.
Both are left.
Recursion. Actually, Sublime will not support an input function. Okay. So we no, we do not have a concept of providing a priority here, but let me just quickly check. Do we have something like this? Okay, so while defining the thread, I can define group none. Alright, so we have something for feature extension, name, keyword arguments, given. So it looks like in init I cannot specify anything called priority. Okay. So I'll just check is there anything else, but with the normal threads I don't think we can define a priority here. Okay, but tomorrow if I found something I'll we'll discuss it tomorrow. Okay. And for I'll just show you the method name and so I can see something input. So, okay, so it will take. So this is a function input, and you can specify a message which you want to give it. Okay.
It takes everything at this string.
It takes as a string. Looks like yes. Yes. Yeah, everything will be string. Okay. So Sublime will not actually support the same method, so it will just fault it. If you want to work with the same thing with Sublime, first you have to install something called Sublime Package Manager. Okay. So this is completely Sublime extension. Actually, I was having in a last old system, but in package control, then you can install it something called Sublime. We so we have one package called this one. Okay, so this is extension of a Sublime actually. Sublime Ripple. Okay. Once you install it, actually, it will give you the new build system. So tools, build system. So here you will get a Sublime Ripple. So here we have Python, we will get Sublime Ripple. So now each type I already have it. Wow. Python. Okay. So now if I execute this, it's executable. Right, so I'm not starting the thread. Into the print. Yeah.
Drawing text from the replay.
There it is.
You don't install.
Actually, I don't know when I installed this Sublime Ripple, but here I guess it must have gotten installed from Anaconda defaultly. pathing, virtual environment, high pathing, variant normal pathing. So, okay, so this is working. Okay, so this is working from here. Build systems.
Total we see, right? Sublime total. Parameter we can pass anything like replace a cursor after printing that value. Like I just used example. So when I execute this, so that time here it's not showing the cursor.
It's not showing there.
Yeah, it's not showing the cursor here.
So you use the input method there?
Yeah, input method.
Oh, it's defaultly not taking the cursor there. Defaultly, it's not taking the cursor there.
No.
It should actually. It should.
Now it's showing here.